And sorry, if you guys don't know, there is water at the back end of this hallway. There's a kitchen, and it says Synovus glasses. You can grab a glass, and then there's a water filter tap just next to the faucet. If anyone is dying of thirst. Okay. All right, so this microphone is actually for our live stream, which is why it doesn't amplify my voice, but I'm really loud, so not to worry. All right, my name is Carmen Velasquez. I'm with Dark Horse Analytics. We are analytics and visualization company out of Edmonton. How many of you have been here before for Lunchalytics? All right. Okay, so half of you have and half of you haven't. We have run Lunchalytics out of Edmonton for the past 4 years, and it's really created a very strong data science community there. The whole goal of this is to have someone come and present a problem they had with data and then how they solve that. So either using tech or what tools they would have used to solve it. And really what has been really good in Edmonton is that people walk away and think, okay, that wasn't my industry, but I have the same problem, and so how can I apply this at where I work? And that's really been the value for us. So we started here in February and hope to build a data science community just like that. All right, and please eat lots of sandwiches, or else we have to take them back to Edmonton, and nobody wants to do that. So help yourself. So this month is on energy. So we have 2 presentations. Our first one is Margaret, and she is with the National Energy Board, so she'll be presenting. And then we did have a speaker, if you looked at the original website, it was going to be Saeed from ATCO. But since I booked him, he actually resigned from ATCO and has joined ATB. And so that no longer worked. So it was too bad. We only found out yesterday, but we're going to do the backup, and we're going to present a crude model that we have built. It's taken us some time to do that, so we'll walk you through that. Our intention is not usually for Dark Horse to present. It's actually to get other participants in the community to present. So if you want to present in the future, you should totally give me a call. All right, so we're having today's session, and then the June one I actually found out just got moved. Synovus needs the space on June 4th. So we're actually going to do it June 11th, and it's going to be on workforce analytics, and Kevin, who's sitting here, is one of the presenters, as well as Christine from Enbridge. So they'll walk you through that. All right, and then we're going to take a break for the summer, and then we'll see you guys again in the fall for Lunchalytics. So that's the plan for the next few months. All right, Margaret, I will pass this on to you.
Okay, thank you very much. Thank you, Carmen. Thank you for the opportunity to present. My name is Margaret. I'm a senior analyst at the National Energy Board, focusing on natural gas market developments, kind of tracking that, as well as some rate hearing stuff. So I'm from the National Energy Board. So the National Energy Board is located here in Calgary. It's a federal agency that regulates pipelines. And so it's a full life cycle regulator, so everything from construction, operation, abandonment, and its governance, if you will, is set up in the Act. So there's various provisions in the Act that kind of dictate everything that we do. And as part of sort of the NEB implementing its governance structure, we also have an energy information program. And the Energy Information Program is a big chunk of the board. There's an entire sort of portion of our site dedicated to it. But it's to present the sort of energy information to Canadians in a sort of non-biased, plain language kind of way. There's a whole set of products that we do. So there's various reports from being multiple pages to short snippets that we do every week. There's sort of our flagship products, which is the Energy Future. So the NEB does a big forecast for energy consumption going out to 2040. We do that on an annual basis. And I'm here to talk about a particular product that we do as part of energy information, and this product is called the Pipeline Profiles. So Carmen said, what was the problem, and I'm kind of here to explain it. So the problem, the issue that we had is the NEB regulates over 100 pipelines, and we wanted to have a place on our website where people can access information in an easy way. The reason I say easy, because before this product was launched, we have a section on our site, it's called Reg Docs, and this is a section where participants to hearings, to any kind of application, anything related to the board, it all has to be public. You have to file information, and this is a tool that we use for people to sort of communicate with the board. So you file information through the system. So it's called Reg Docs. There's millions of documents in there. It's all PDF. And so if somebody, if a participant or an interested party or anyone in the public wanted to kind of see information, they do have to have, there's a bit of a learning curve to access information. So it's not intuitive per se to access information. So what we wanted to do is we wanted to create space on our website that if somebody wanted information on the Trans-Canada Main Line or the Enbridge system, can just come on in and everything will be there spelled out for them. That was kind of our vision, and it was there was two sort of issues in addition to that. There's plenty of data. So there's data on these pipelines related to financials, to construction, to environmental, to abandonment, to tolls, to the price to ship product on the pipeline. But again, this information was in 5,000 PDFs, difficult to navigate, and so we had to come up with a way to grab that information, make it machine readable, easy to access, do something with it. And the other thing that we had to do is we changed some regulations requiring companies to file information on the flows on these pipelines and kind of the key points. So once we had all of this information in place, the tool that we kind of focused on was Tableau. A couple of reasons, obviously, but the easy part, the nice part with Tableau is that any analyst can kind of do it. You don't have to do custom code. You can just kind of drag and drop various filters, various information into your workspace. And what we do, once we have these dashboards done for traffic data, so we call it traffic data, but really it's pipeline flow data. So on this particular slide, the information looks like this for the flows. So we have daily flows on the key pipeline systems, and this information is updated quarterly, as well as the capacity. So there's a bunch of toggles that people can use to change the key point that they want to look at a particular pipeline. And like I said, it comes quarterly. We've done some calculations about annual flow rates. Of course, if you work in energy, there's a gazillion units. So do we use billion cubic feet or cubic meters, GJs, barrels per day, per month, per year? We attempted to standardize some of these units, so people do have the ability to change the units here. And this exercise required us to make this information also available for the public. So we're the public service. All of this information is available in OpenGov. OpenGov is kind of the site that the federal government requires, various government departments to kind of park their data, again, making it more accessible, so anyone can access this data. And so that's on the flows side. We wanted to do something on the tolls as well. Tolls is a big feature of pipelines, of course. Transportation costs are an important factor in determining any kind of analytics related to the energy sector. For this, we couldn't force companies to provide this information to us in a standardized format like we did with traffic data. And this is because pipelines have all sorts of different arrangements, different services. So kind of attempting to standardize a template, and again, going retroactive, it wasn't going to make sense. This information is available in the NEB Reg Docs, but it's in these esoteric PDF files. So, like I'm sure many other businesses, we got some summer students to come in, and unfortunately they had to input this information by hand, but at least we were able to go back for the various pipeline systems, go back historical, and now we kind of have a template moving forward, so it saved us many, many hours of kind of figuring out how to do this, as well as the updating procedure. So the good news for the public is that for the 15 the major oil and gas liquids pipelines, oil and liquids pipelines, and the 10 natural gas pipelines, so the 25 sort of bigger pipelines, this information has been collected. It's also available on OpenGov for sort of the main paths, if you will. And this has also been incorporated into the pipeline profiles. In terms of cool ways to automate it, we do have tools that we use to automate sort of the updating procedure for this. So again, before it would have taken hours to get this information by hand. Now it's just click and everything automates by itself. So this was awesome. So this has become our flagship product, if you will. A lot of companies who require the submission of what flows on their pipeline will actually direct their shippers to see the the NEB data. We have, in terms of when we get the data on a quarterly basis, we have within the day, it's already updated because again, we're using automation tools. And it's on our website, of course. So this has really become the flagship product of the NEB. The presentation after me is actually going to be using, not using, but they do use some of this data, so that's awesome to see. Of course, I'm sure others are using it for many different purposes. The intent ultimately is not necessarily just to allow people to build various models, but it's kind of to inform Canadians about what's shipping in the pipelines in their backyard or in their vicinity, just to give more information about where the pipelines are and what the content and what the daily flows at various points is. Let's skip that one. Does it show? It shows here, it doesn't show here. Oh, there we go. Yeah. Sorry. In addition to using Tableau for our pipeline profiles, we also have, like I said, we have these things called market snapshots. And market snapshots are short, two-paragraph kind of descriptions of what the current events happening in the energy industry are at the moment. Plain language, kind of non-biased, and very often this is associated with as a graph, and all of these graphs data. So you can check it out too. And in addition, I just want to just add, we use Tableau for most of our stuff. We do have some custom visualizations that we've implemented on our site. I mentioned earlier that the NEB does this big energy forecast, so out to 2040 for the various commodities. So all of this information, the data from that particular report called Energy Futures, so every year it's Energy Futures 2018, this version is going to be 2019. You can come here and play. These are more sophisticated than Tableau. These are custom, I believe they're done in D3. Quite a bigger enterprise. It took a little bit longer than just a quick Tableau dashboard. But we have these custom D3 visualizations for this EF product, as well as various pipeline incident data. That's something that the National Energy Board collects, makes it available so people can come in and sort of look at that data as well. And of course our imports-export data. So there's the National Energy Board under Part 6 of the Act is responsible for regulating imports and export of these commodity products. So there's a lot of information related to imports and exports commodity within these customized visualizations. And then this is great for our management because they're super happy with it because in terms of hits, interactions, feedback, this has kind of become, the pipeline profiles have become one of our most important and frequently accessed sources, products. And lots of feedback. These things are continuing to kind of change as we get new ideas and as we get feedback. So this is our flagship product, and the data kind of reinforces that we went the right route with some of this stuff. And finally, there's some NEB data that we have on our website. There's links to all of this, so you can check out the presentation if you want to open up data for tolls. And for traffic data, it's all available online. And then there's links to a bunch of other data sets that the NEB collects. So that's my 15 minutes. And I'm very happy to answer any questions you may have. Yes, sir.
How do you like working with Tableau versus other products that you could have chosen?
Yeah, Tableau, and I'm not getting paid to say any of this, but absolutely, it's been transformative. For us, we were kind of in terms of the federal family, if you will, maybe not, corporate-wide, but in terms of the federal family, we've been the first, definitely, to kind of to uptake Tableau. we just gave it out to the analysts and let them play with it, and it's been transformational and absolutely changed everything for us because the ability to parse the data, all of these colors, play with the tabs, like it's been fantastic. The one thing that it really highlighted for us, and it has become an issue that continues to evolve, and it's perhaps not solved yet. Your data has to be absolutely perfect and clean for Tableau to be able to play with it. So we had a analysts using like everyone siloed. So it's in this person's Excel sheet on their desk, but it's not standardized. So we had to set up a working database and get people used to using SQL versus just playing in Excel on the side of your desk, right? So using Tableau forced us to get our data in order, and we've made milestones. Is it perfect? No, but it really, and it got our management's attention, if you will, to recognize it as an issue. So it's been a great tool, but also caused us to fix our data, and that's a challenge for everyone, for sure. Yeah.
Yes. How long has it taken from the time you thought, like, let's do these pipeline profiles to actually getting this in place? Like, is it years of time?
Oh no, not at all. Again, the idea, the seed to kind of do something with it was always there. To be completely honest, Carmen, when the regulations change, requiring companies to file the traffic data, like we knew that this is a little gold mine, and we need to capitalize on it because we don't want consultants to come in and take our data and then charge $10,000, to make it available. So that plus kind of we got Tableau, so it's sort of the stars aligned, and in terms of timing, it was led by a pretty small team of people, maybe 3-4 people, between kind of the go ahead from management to completion. It was less than a year. It was maybe 6 to 8 months, yeah. And it evolved. We have 25 now. We did not start with. We started maybe with 7, and then 8. It just grows. It continues to grow. Yeah. Yes, sir.
How granular is your data? You talk about quarterly information. So is it given to you throughput by month, and then you just average it out, or you sum it and you give a quarterly flow? And also, on the granular question, not all crude's created equal. Just speaking
Absolutely,
of crude,
yeah.
do you have volumetric breakdown of like this is your C5, this is your classed as sweet, this is your classed
Yeah.
in the whole batch? Do you have that
so
data?
okay, so for gas is daily. You
Yeah.
get it daily. Crude oil is monthly, and crude oil. Do we have it by type? I think.
Heavy, light, and RCPs?
Yeah. So just that level of detail, and it's monthly. So not super duper helpful, but some of the the issues was, well, there was issue even providing that if we wanted to make it consistent with gas, which is daily.
Yes.
There were issues about providing this data, so it's monthly. But not to say, this is constantly in flux. So if there is a particular need, then that's something that we can consider for information.
Thank you.
Is the difference in time because gas just is a faster cycle, like domination wise, or like do you know what the delay is?
In terms of it's still quarterly, so it gets filed at the same time. It's just the level of detail is different.
Okay.
Yeah, I'm not 100% sure about that, but gas, I guess, because it doesn't have the batch problem, and it's just one single thing, maybe it's just easier to get that level of detail. Yeah.
Any other questions? Okay, so can I just give you a plug, because I actually use this data all the time.
For
And
sure.
I think it's been really helpful for things like what flows on the Trans Mountain pipeline. I don't know if you guys are in these debates, but like, is it heavy, is it light? And then you can now just go to the pipeline profile. It's like, ta-da! It's both, although more heavy was running on certain months, which you'll see kind of in the news later on. So it's actually been really useful for that. Do you have any plans to change, like, because the toll information is really hard to get. Like, we all have to go through the docket. So now that you have this, are you actually going to streamline the back end too for people to be able to scrape that easier?
So the toll information that's in the pipeline profiles,
Yeah.
you can go to the OpenGov and grab it. It's on a daily basis.
Right.
But we do recognize that there are many paths on systems that we kind of went with, the big ones, the main
Yeah.
ones, and that's what we have in OpenGov.
Right.
There are more. Again, if there's interest in that,
Right.
definitely let us know. Yeah, let us know what kind of data is useful for people. not everything,
Yes,
but yes.
yes.
Yeah.
Okay,
Yeah.
cool. Thank you. Thanks, Margaret.
Thank you.
All right, now we're going to switch over to Craig, who's going to present on our behalf, although I feel like I might interject as we go. You'll see. So before I do that, a couple questions or a couple things for you. One is we always want to acknowledge the sponsors who paid for the lunch that you are eating today, which today is ATV. And we also want to thank the Nucleus for the space being available for us here. The other thing too is we try to hook you up. If you're looking for a job and someone's hiring, man, we can like connect you. It's like dating, but for jobs. Just probably the original website. So is anyone here looking for a job? Is anyone here hiring? Not today, or maybe? Kevin looks like he might be hiring. This is Kevin from ATV, everybody. Okay, so you can come and talk to him after. So the other thing too that I wanted to say is that, because we are nearing the end of the season, so we just have the June Lunchalytics one to go. I will send out a survey. I think I said I was going to do that last time and then I didn't, but this time I will send out a survey just to understand what you like about the meetup, what you think we can do better, what other topics you want covered. If you have any speakers that you would like to recommend to us, that would be really helpful. And the other thing too is for us to understand who you are, just so we're making sure that we're tailoring this properly. Because I know some of you are data science practitioners, others of you are managers, and others just come for interest, but it would be really helpful for us to know what all we should be presenting. So I'll send out a survey through the meetup site, and then if you could respond, that would be great. Am I missing anything else? That's good. Okay. All right, so we're going to move on to a model that we have built called Model CrudeFX, and it solves the world's crude problems. It solves those blows. Great.
Okay, so I was tasked with coming up with a presentation yesterday afternoon when our speaker canceled, and I succeeded. It's amazing. So the sort of focus is, so we have this CrudeFX model that predicts trade flows in North America for oil. So I'll tell you a bit about the model, but also using that model, I figured the application that I would do is production curtailment, because that's sort of current, maybe a little historical, but sort of current. So let's get started. Just a clicker.
There it is.
Nice. Okay, so CrudeFX is a model that we built to evaluate a couple different things. So I classify it as an economic model. We wanted to evaluate the market effects and price impacts of things like changes in pipeline capacity. So if pipelines are built or not built, how does that change market outcomes? But also if a pipeline has a leak or something and we have a quick shutdown, how does that change trade, and what sort of market forces will determine prices at that point in time. As well, we wanted to evaluate changes in demand over time. So in the future, if demand is growing, like if more refining capacity is being built, how does that change trade? But also, for example, what might happen during turnaround seasons. So if a certain number of refineries are undergoing maintenance, or maybe certain units are undergoing maintenance, how does that change trade? Or on the supply side, maybe there's a fire in northern Alberta that really disrupts production of oil, and how might that change things in the market? And for putting together forecasts in it. So this is the lay of the land of the model. So basically we divide North America into these regions. So Canada, we have the West Coast, we have the Western provinces, we have center, and we have east, and we divide the US into its pads. In fact, on the map and on the tool that I'll show you, we show only pad 2, but underneath the hood, we subdivide that into north, mid, and south, corresponding roughly to Superior, Chicago, and Cushing, for those who know those places. For each one of those regions, each one of the nodes, we need to make an assumption about supply, so what sort of supply is going to come out of that node. And we also need to know what sort of demand is in that node. So what's the refining capacity there? And we do that by grade. So in this model, we have two commodities. We have light and heavy oil, which is just reality. Actually, we always get feedback that it's infinitely more complicated than that. And building these models is always a trade-off between usefulness and complexity. So we felt it was a useful decision to have light and heavy. As well, if we want to know something about trade flows, we need to know about pipeline capacity between each of those nodes. We want to know what the capacity to send barrels by rail is between all of the nodes, whether any barrels will go by tanker or barge, and we might want to know what import and export capacity is at each one of those nodes. The other thing that's secretly hiding behind this, on this image and on the tool, I have a single node that represents imports and exports, but in fact, the model has a bunch of global regions in the background as well. When we fit our model and we make predictions, we only show North America, and that's because compared to global trade, trade in North America is pretty transparent. We can see that data and see whether the model is working, whereas the international piece is not so reliable. So I trust what the model will say about imports and exports, but not necessarily where they're going to or where they're coming from for North America, if that makes sense. So then we have our capacities, cost data. Margaret, yeah, I know. Margaret was talking about tolls and toll information. So we, when we built this model, hired a summer student to gather all that toll information for us. So at the time, none of these sort of NEB portals were available, and certainly in the US, there's no real FERC portal. So it was very much going through PDFs and finding the committed and the uncommitted rate and putting them in a spreadsheet and taking averages and stuff. So that's the starting point for our costs. For prices, we, when we look into the future, we use EIA price forecasts, but ultimately we can put in whatever price forecasts we want. And then we maximize profit for the industry and we get trade flows. And these are some of the data sources that we use. Right. So the one thing is that that transportation cost piece is really critical. If you just grab the uncommitted rate from regulatory filings and you solve the model, it won't reflect reality. And that's because there's committed and uncommitted shippers, there are intermediaries, crazy things happen. And so we have this network optimization that figures out trade flows, but we have another layer of optimization that sort of figures out what the appropriate transportation costs are. And that's how we get it to fit. And so we fit it to historical data, and then we do a holdback to sort of validate it. And it is not perfect, but I think that it's really, really good. Certainly, by figuring out those transportation costs, it fits way better. And when we actually do some marginal barrel analysis, it becomes clear that it's probably correct. And in the very worst case scenario, it's still extremely useful if you're trying to understand what's happening in the market. So we validate it. Is it right? If you ask me, it is so right. But the further you look down into the details, you might start to question it. So we just won't do that. Okay, so what I had to do yesterday was quickly put together a bit of an analytical case. So I decided to do the Organization of Petroleum Exporting Province and look at curtailment decisions that were made in Alberta. So the original sort of quoted number for curtailment was, I think, 325,000 barrels per day. That was what we all saw in the news, that the intention was that Alberta would be producing that's what I did. Okay, so let me just go to the tool.
Did you move it?
No. I'll load it. Okay, so what you're seeing here is a modeled output for trade flows in North America. So we, in fact, remember how I talked about fitting the model? We fit it on some 2017 data. So this is a little outdated from a fitting standpoint, but it's also a bit of a holdback case. So you can think of it as we fit it in the past, and now when we fit it, 2018 was still the future. So, as I said, this is a modeled solution. And so the purple arrows are import and export from North America. The green arrows are pipeline flows. Orange arrows are rail flows. And technically, they're supposed to be blue arrows, but I just realized that when we pushed the latest update, they appeared as green. But these ones would be tanker and barge flows. So, sorry about that. So, what we can do with this, or with the data that I've loaded in the tool, is I can, so we're looking at all flows, so let's look at heavy, because that's what Alberta cares about predominantly. And if I look at Western Canada, the model says that in 2018, the marginal price setting barrel from a transportation differential perspective should be a rail barrel from Alberta to the Gulf Coast. So that's interesting. I can advance the model to 2022 and we'll see some small changes. What you'll see is that the rail flow to the Gulf Coast will grow and imports and exports from the Gulf Coast will change because US production is growing quite a bit. So I'll advance that to 2022. Now, there are a couple things that may or may not happen in the future. The first one being expanded capacity on Enbridge via Line 3. The second one being Keystone XL. So if I turn on Line 3, well, first let's see this thing. If I turn on Line 3, it's not enough capacity in 2022 to change the economics of the marginal barrel. We'd say it's still a rail barrel to the Gulf Coast. But these arrows, representing heavy flows through the West Coast down to Pad 5 appeared, indicating that there would be more of an incentive under Line 3 because it's a mixed line to ship heavy barrels to Pad 5. Next thing that may or may not happen is KXL. In that situation, we see, okay, that is enough capacity in 2022 to buy a few years, presumably, of pipeline economics. So that's 2022. 2019, that's where we're at. So I did this curtailed thing where I just reduced Alberta production by 325,000 barrels per day and looked at the marginal barrel for Alberta. In fact, when I solve the model, I actually iterate through and I do the marginal barrel in and out of every region of the world. But we had never done that before, and so when we loaded it into the tool, it broke it because there are all sorts of interesting results that you see. So, for example, the last barrel produced in the Gulf Coast would be an exported barrel. And so that actually, rather than seeing in Alberta where it's just like, okay, there's this line, it kicks out an import and then somewhere in the globe has to produce one less barrel, and it has all sorts of pecuniary effects in the rest of the network. And our viz in its infancy could not handle how complicated it was. So, 2019, pre-curtailment, we're looking at rail to the Gulf Coast, which I think makes sense. And when you do curtailment of 325,000 barrels per day, you get pipeline economics. So when that happened, Carmen and I, who are in the same office, we were like, oh, this is so crazy because the differential narrowed to like $7 at one point. And we were like, wow, that is really narrow. But after doing this, I was thinking back to it, and it narrowed to $7 to WTI. But in reality, what we need to be looking at is the differential to a global benchmark of heavy. And so if you look at a global heavy, that transportation differential was $11, $10 or $11, which is pipeline economics to the Gulf Coast. So that was cool. And then, last but not least, since the original curtailment decision of 325,000 barrels per day, they've slowly ramped that down by about 150,000 barrels per day. So technically curtailment, according to these like made up numbers, like it's actually a percentage, but should be around 175,000 barrels per day. So depending on what the government's goal in this situation is, I'm not sure what the right answer is, but if they had asked me, and they would have said, I'm assuming that they want to ride that balance between pipeline economics and rail economics as a price-setting barrel, my model would have said that they should curtail by 171,000 and some change barrels per day, which is very, very close. And I was real happy about that. And that's it. That's my presentation. Are there any questions? Yeah.
So I like the toggle that you put for the various scenarios, yes or no. Have you thought about adding in this turn off the taps bill?
Yeah, I've thought about it. I've thought about it.
What do you think? How do you think the marginal barrel would behave if
I don't know. I don't know. That's a good question. So the model, the way it's set up, I'm saying that all of the North American regions must, that there's an equality constraint. So whatever your supply capacity is, you have to produce it. So the model, in absence of capacity going to the West Coast, would find a way to ship those barrels. And so I'm guessing it would increase rail shipments and decrease imports into the Gulf Coast. And so it would still be a marginal rail barrel, but more so. The other thing that's interesting is, with this, we can start talking about the sensitivity according to rail capacity. So if all those barrels must now travel by rail, is it reasonable to assume that Alberta can onload and send 500,000 barrels per day of rail? Maybe not. And you can start, just based on what happened in the fall, you can start to ascertain what that capacity limit on rail might be. In the model, I just let it be free as a marginal thing. Yeah. Yeah.
Great tool, by the way. Is your model, would it be able to accommodate, sorry, I'm asking for features already.
Yeah, that's great.
Would you be able to have a range of curtailments, let's say, or a range of rail barrels?
So, well, I'd have to run them. So
Okay,
so right now, it's a good question because it's something that I've thought about. So typically when you do Tableau or Power BI, you have a data model where you drop down menu, select this, and it filters the records and shows it to you. In this instance, the data model would actually be that optimization model. So we'd have to have a slider, and it would have to do a server call, solve the model, and bring the data back to you. Yeah. And it doesn't do that right now. Anyone else? Yeah.
I'm just wondering, when you were speaking of the initial margin of error around human data entry, or there must be a margin of error, how will this evolve in terms of artificial intelligence and using modeling this?
AI and this? Okay, I can come up with an answer to that. I think that for this type of analysis, so number one, this is very economic analysis. And so we're really looking at ceteris paribus, understanding how the world might look in the future. And the way that AI can help in that is actually probably making this model more accurate. So the real challenge in getting this model to fit in the first place is the granularity of the data. So I predict the flow of light and heavy barrels between all of these regions, and I try and fit it to EIA trade data. But EIA trade data is only oil going from, for example, pad 2 to pad 3, not pad 2 north to pad 2 mid to pad 2 south to pad 2 3. So I actually have to do a bunch of fancy tricks to aggregate up my solution and try and make it match. So I'm solving this really high granularity problem and comparing it to something that is really low resolution. And I think probably the opportunity for AI is simplifying reporting that data. It's hard to do right now, and we rely on people filing that information. But you can imagine a situation where pipelines are tracking batch shipments, and there's a sensor that figures out what it is, and it gets reported back, and it's just stream data, and it's live. So I think in that situation, I could have data that matches the resolution of my model, in which case I would go ahead and make my model greater resolution and still aggregate it up and see what I can predict. Yeah. Yep.
The visualization there is really impressive. Is there a sort of a trade-off with not having numbers on there in terms of people's ability to, I guess, comprehend?
Yeah, so I think, yes, that's true, but I also think that this is like a development version, so it's a little underdeveloped, and I think some numbers would be useful. So again, for example, when we're talking about the data model, I think that something that is missing from this viz is a view of your input assumptions. So the map is showing you the model result, but what are your assumptions around supply and demand and that sort of thing? And I think some additional context around that is what, it is what we're pursuing at present. Yeah.
Any chance you could mention what tools you use to develop this, the stack, or is this proprietary?
Sure, so the map, the viz is D3. I didn't do it though, so I can't give you much more information than that. The network model I wrote in Ample, it's a math programming language. I manage data through a combination of R and Excel, and I do optimizations, all the layers of optimizations I do in R. And so when I do that optimization, actually I have to spin up a bunch of Amazon instances because it takes so long to find those transportation costs. It's really discretely nonlinear to find that solution. Yeah.
How long does it take to just say something is announced in the news today that we are closing a refinery or banning shipments to a province? How long would it take to run that scenario?
That would be really quick. So that big optimization that takes forever, we only do that maybe once a year, but to do those sort of quick analyses, for example, curtailment, I ran that scenario and did all the marginal barrels yesterday afternoon, so it would have been an hour or two to get like very complete results. Interpretation of those results might take longer than an hour, but actually doing the calculation is very fast. Okay.
Awesome.
Thanks.
All right. All right, so thanks to both our speakers today, Margaret from the NED, Craig from Dark Horse, and again, we'll see you June 11th for the next meetup, and I'll change all that on the meetup site, and if you have any questions, these guys are still available for the next 10 minutes. Thank you.